Okay guys, so this is going to be some review of section 5.2. Begins with some polynomial vocabulary. So let's start at the beginning. Listing the terms in the polynomial. You have to realize that the polynomial has different pieces to it, different parts to it, and so each of those parts is called a term. So if you look right here, the first term is 7x to the fifth. The second term is x squared y squared. The third term is negative 4xy, and the fourth term is that positive 7. Okay, so you'll notice that the terms are separated by a positive or a negative sign. Let's get a little closer here. Okay, so they're separated by these positive and negatives. So every time you see a positive or a negative sign, you know you're moving to a new term. So this polynomial has 4 terms, 1, 2, 3, 4. The coefficient of the term 7x to the fifth is going to be the 7. And remember, the coefficient is this number that's being multiplied by the variable term. And so you have x to the fifth being multiplied by 7. The coefficient of the term x squared y squared is actually 1, because you can think of this as 1 times x squared y squared. The coefficient of negative 4xy is negative 4. And then the term 7 does not have a variable in it. So the term 7 is actually what we call a constant term. So we don't list a coefficient for that because 7 is a constant term. It does not have a variable. Now sometimes we think of this as 7 times x to the 0 power, but 7 itself is actually just a constant term. Alright, so let's fill in the blank with special name of each polynomial. So a polynomial with one term is called a monomial. A polynomial with 2 terms is called a binomial. A polynomial with 3 terms is called a trinomial. Okay, now let's move on and let's talk a little bit about finding the degree of a polynomial. Okay, so finding the degree, what you have to do is you have to look at the polynomial and you have to think about the exponents that are on the variable pieces of each term. And so here we have the term 9y squared, and you only look at the exponents that are on the variable part. And so 9 is actually equal to 9 to the first power, but we're not concerned with the 1 for the first power of 9. We're only concerned with this 2 that's right up here with the y. So the degree of this first term is a 2 because it goes to the second power. Okay, when we look at the second term, this y has an exponent there of 1. So the degree of this term is 1. And then this negative 7 can be thought of as 7 times y to the 0 power. So what we look at here is this little 0 up here. So we'd actually say that negative 7 has a degree of 0. And so when we look at this, we choose the largest degree. So the degree of this polynomial is going to be degree 2. And we have a second question to answer, and that is it a monomial, binomial, or trinomial, or none of these? There are 3 terms in this polynomial, so we're going to call this a trinomial. Okay, let's take a look at this second example here, example B. Okay, and so we have 6x, which is like 6x to the first, so the degree is 1. 4x to the third, the degree is 3. 5x to the second, the degree is 2, and this is negative 3 times x to the 0 power. And let me just remind you again where that comes from. Anytime you multiply, anytime you have anything to the 0 power, we discussed anything to the 0 power is actually 1. And so x to the 0 power is the same thing as 1. So that's why we can say that negative 3 times x to the 0 is equal to negative 3. This is like multiplying negative 3 times 1, which is still negative 3. So this is to the 0 power. And the highest power that we have here is 3. so our degree is 3. And this is not a monomial, binomial, or a trinomial because it has more than 3 terms. So we're going to say that it's none of these. Okay, now we're going to determine the degree of each term in this polynomial and then the degree of the entire polynomial. Okay, so if we look right here, we have 7x squared y, and we have to think about the exponents that are on each of the variable terms that you see here. So we have x squared, and this is y to the first. So what you'll do is you'll add these exponents here. So we have an x squared and an x to the first, so that's a total of 3. So the degree of the first term is 3. When we look at the second term, this is x squared, y to the first, z to the first. So when you add 2 plus 1 plus 1, you actually get 4. Okay, then this 2, that's just a constant term. And remember, it's kind of like 2 times x to the 0 power. It's going to have a degree of 0. And then we have this last term that has a degree of 3. So we have a degree of 3, 4, 0, and 3. So listing the degree of each term. And then the degree of the entire polynomial, when you take a look at that, is going to be the highest degree of all of them. And so 4 is the highest degree. So we'd say that this is a polynomial of degree 4. Okay, so let's move on. When you have a polynomial function, you can substitute values in, or replacement values that you can use here. So what we're going to be doing with this is, it says p of x is 3x squared minus 2x minus 5. And we're going to do p of 1, which means everywhere we see an x, we're going to plug in a 1. Okay, so we're going to come to this equation, this function, and instead of 3 times x squared, we're going to do 3 times 1 squared minus 2 times 1 minus 5. And again, we're just replacing the x's with this 1. Okay, so let's use our order of operations. Looking left to right, we don't see any parentheses except these, but these are indicating multiplication, so we go on to our exponents. And 1 squared is 1, so we have 3 times 1, minus 2 times 1, minus 5. Okay, 3 times 1 is 3, 2 times 1 is 2. Put a minus sign in between there. Okay, and left to right, addition and subtraction work left to right, so 3 minus 2 is negative 1, and negative 1 minus 5. Oh, not negative 1. I messed that up. Excuse me. 3 minus 2 is positive 1, and then positive 1 minus 5 is going to equal negative 4. All right, let's try out the next one. We're going to be replacing the x value with a negative 2. So let's do 3 times negative 2 squared minus 2 times negative 2 minus 5. Okay, working left to right, we're going to look across and see what we have. Okay, so we have some multiplication going on. We have some exponents. So we're going to go to those exponents first. And remember, negative 2 squared means negative 2 times negative 2. Okay, so that's negative 2 times negative 2, which is positive 4. So this actually becomes 3 times 4 minus, now we have to figure out what this is right here. What is 2? 2 times negative 2 is negative 4. So we have to subtract 2 times negative 2, which means we're going to subtract negative 4. And then we have minus 5. Okay, now we see some double signs right here. So let's go ahead and take care of that. Subtracting a negative, same thing as adding. Okay, so what we really have is 3 times 4 plus 4 minus 5. And we're going to go ahead and do our multiplication. 3 times 4 is 12. Plus 4 minus 5. 12 plus 4 is 16, and 16 minus 5 is 11. All right, now let's move on to combining like terms and simplifying polynomials. So what we're going to do right here is we're going to look for anything that they have in common. So the like terms will have the same exponent on the variable. So here this is negative 6 times y plus 8y. It's as if those both have a first power up there, so those are what we call like terms. Okay, so we can go ahead and join those like terms together. So we have this negative 6y and this positive 8y that can go together. Okay, negative 6 plus 8 is 2. And so we have 2y. Okay, then looking to part B, we have 14y squared and minus 10y squared that can go together. 14 minus 10 is 4, so we have 4y squared. All right, and then we have a positive 3 and a negative 9 that are like terms, because those are constants, and 3 minus 9 is negative 6. Okay, these are like terms because 7x squared, x to the third power, or what we call x cubed, can be joined with x cubed. Now you might want to put in a 1 there to remind yourself that the coefficient of that x cubed is a 1. So you have 7x cubed plus 1x cubed, which makes 8x cubed. Okay, looking at part D, the like terms we have here is the negative 6x and this negative x, and you might want to again remember that the coefficient of that x is actually a negative 1. So when you join those together, we have 23x squared minus 7x squared minus 15. Okay, and then this last polynomial, right here we have an x squared y. So what we do is we have to come over here and look for anything else that has x squared y. And we see that right here, this positive 10x squared y. So let's go ahead and join those together. This is like a 1x squared y with a 10x squared y. So that's going to be 11x squared y. Okay, now we also have a positive xy, and here's another positive xy. So thinking about their coefficients being 1s, this is a 1xy with a 1xy, which is a 2xy. And then we have a third term here that we can join with another one. We have this negative y with this negative 2y. And so when you put those together, that's a negative 1y with a negative 2y, which is a negative 3y. Okay. So we have simplified this polynomial.